Hey there, Mr. Weaver here, and this is topic 2 and 3, lesson 8, graphing slope-intercept form. After this lesson, you need to be able to use the rate of change and y-intercept to graph a line. You'll know you're successful after this lesson if you can draw a graph of a given equation. When we're graphing equations, we want to know what the graph of the given equation looks like. So our question here, what does the graph of y equals 4/5 x plus 2 look like? As with all the things in this chapter, our graph should end up being a straight line, as these are linear functions. So to graph this equation, first, we're going to identify and plot the y-intercept. So, in the equation, the y-intercept is that plus or minus number at the end, that b. So, in this case, our y-intercept is positive 2. To plot that point, we just start at the middle and then go up 2, because that y-intercept is how many up or down it's going to cross. So plus 2. Then we're going to use our slope to plot a second point. So the slope here is 4/5. Now if you think back to the previous lesson when we were identifying what the slope was from the graph, we counted how many spaces up and how many spaces over we moved to go from one point to the next. So if we think along that same line, the slope here is telling us to go from one point to the next, we need to move 4 units up and 5 units to the right. The top number is positive, so it would be up, and then we're always moving to the right. So I'm going to use that pattern, 4 up, 5 to the right. So starting at my dot, I'm going to count 4 spaces up and 5 spaces to the right. And I'm going to plot another dot. To get a more general idea of what my line looks like, I can keep following that pattern again. So from where I left off, 4 up, 5 to the right, and I can plot another dot. If I want to start working in the opposite direction, I just need to work backwards and imagine that had I went 4 up and 5 to the right, where would I have started? Finally, I use a straight edge and draw a line through all the points. Now, these lines do go on forever and ever, so we should draw arrowheads going from the ends in both directions. A quick way to check to see if you were doing stuff right. First, did it make a straight line? If not, something's wrong. Second, if you notice my orange arrows here, they almost look like stairs. So I had to follow the same pattern. My stairs didn't change size as I was going from left to right. Now it's your turn. Pause the video and graph y equals 1/2 x plus 2. So we can see what that looks like. Check your answers. So your y-intercept should have been at plus 2. And it's going up 1 over 2 each time. So your line would look like this. Let's look at another example. So this time we have y equals -1/3 x minus 4. So again, I'm going to start at my y-intercept, which is -4, and plot a point. So down 4, plotted a point. Then I'm going to use my slope, -1/3. What I do is generally move that negative to the top. So I'm going to treat that as -1 and then over 3. So I'm going to go down 1 over 3. I can put my new point. I could keep following the pattern over and over so I can get my general idea. Once I do, graph my line, it should look like that. Each time the line is going down 1 over 3. Down 1 to the right 3. If you remember from the previous lesson, I should know what the graph looks like. Because my slope is negative, it automatically tells me that the graph should be slanting downward, going from left to right. Pause the video and try your graph. Here's what your graph should look like. Y-intercept of -2, and it's going down 1 over 2 each time. Third example. The temperature goes up 3 degrees per hour. So 3 degrees per hour is a rate of change. I can tell by the fact that it says up 3 and it has the word per there. But where do we start? If it does not tell you where to start, we're going to assume that we're starting at 0. So I'm going to put my y-intercept of 0, and it's going up 3 degrees every hour. So at 1 hour, it would be at 3 degrees, 2 hours at 6, and so on. So I would go up 3 over 1 hour, plot my dot, graph my line, and I can see as my time increases by an hour, my temperature goes up 3 degrees. So 2 hours, 6 degrees. 3 hours, 9 degrees. Pause the video and try to figure out what your graph would look like for this context. Check your answer. Yours should have been going down 2 feet per second. Again, we start at 0 because we don't know the y-intercept, so we're going to assume it's 0. Your bird was going down 2 feet every second that passed, so down 2 over 1. Now let's look at some special situations. So we saw in the previous lesson, when a graph does not have a slope, it's really just 0. So this equation, y equals 3, is really just y equals 0x plus 3. So if I were to plot my y-intercept, it would be at 3, and then it would have a slope of 0, so it's not going up or down the entire time. So I would just draw a horizontal line at 3. Pause the video and graph y equals -2. Check your answer. Last, I want to go through a situation that's not common, but you might randomly see it. So just so you're aware. If you have a graph where it's x equals a number. So y equals a number was our horizontal line. X equals a number is just a vertical line where that number is. Here I have x equals 3. I would just draw a vertical line at +3. So pause the video. Where would x equals -2 be, and what would it look like? You should have had a vertical line at -2. In this lesson, we learned that slope-intercept form tells us the two things we need to graph, the slope and the y-intercept. So to graph, we start by plotting a point at the y-intercept, then from that point, move how the slope tells you to move. The top number tells you how many to go up if it's positive, or down if it's negative, and the bottom number tells you how many to go to the right. Follow the pattern. If you're drawing the arrows, it will look like stairs, but generally we would want to erase those at the end, and then graph your line through those points. If it doesn't make a perfectly straight line, something's off. Figure out what you did wrong. So after this lesson, do you know how to draw a graph of a line that's given in slope-intercept form? If you're not sure about this one thing, go back and rewatch some of the examples to see if you can deepen your understanding. And that's the end of lesson 8 on graphing from slope-intercept form.